Now in its 24th year, the Philippine Mathematical Olympiad is the oldest and most prestigious nationwide mathematics competition among high school students. After its trial run in 1984, it was officially launched in 1986 and has been held annually since 2007. The country's contestants to the International Mathematical Olympiad are chosen from the top students who compete in the Philippine Mathematical Olympiad. The PMO is a project of the Mathematical Society of the Philippines and the Department of Science and Technology Science Education Institute.
Hello, followers, math enthusiasts, coaches, contestants of the Philippine Mathematical Olympiad. Let's have a look at the last problem, number 25 of the recently concluded qualifying stage. For a real number x, I'm going to call this the floor of x. So I'll talk briefly later about what this function is. So let the floor of x denote the greatest integer not exceeding x. Consider the function f of xy is equal to the square root of m times m plus 1 times the sum of the absolute value of x minus m plus the absolute value of y minus m, where big M is the maximum of the floor of x and y, and small m is the minimum of the floor of x and y. Wow, daming nangyayari dito. So anyway, hihimayin natin ito mamaya. The set of all real numbers xy such that x and y are between 2 and 2022, and f of xy is less than or equal to 2, can be expressed as a finite union of disjoint regions in the plane. The sum of the areas of these regions can be expressed as a fraction a over b in lowest terms. What's the value of a plus b? So the PMO qualifying stage is a contest where it's convenient to have a single number as the final answer, and it's convenient for it to be an integer. So that's why the problem was formulated as finding the value of a plus b, but really it's the some of the areas that we're interested in. So we're going to be focusing on figuring out what this fraction a over b is. Now the problem is talking about certain regions of which we have to find the area. So ano itong mga regions na to? These are the collection of points xy for which the function's value becomes less than or equal to 2. So I suppose for different values of x and y, the output could be larger than 2. Sometimes it's going to be less than or equal to 2. But apparently, if we want that inequality to hold, that's going to happen when x and y somehow belong to certain regions. So we want to understand how those regions are going to look like. But first, let's have a look at the floor function. So f of x, sometimes denoted by this notation, or this notation which the problem uses. So this is the greatest integer function, sometimes also referred to as the floor function. For those who want to know more about this function, you can refer to videos number 8 and 9 in the current tutorial series that we have here for the Philippine Math Olympiad. So this is the greatest integer less than or equal to x. Here are some examples. Pi is a number between 3 and 4 because it's approximately 3.14. So 3 is the greatest integer just before pi. So what this suggests is to find the floor of x, we round down. So it's not really rounding off because even if it was 3.9, which is closer to 4, 3 is still the greatest integer just before 3. Sorry, just before pi. And then for negative 1.6, which is between negative 2 and negative 1, so the floor of that is negative 2. Pero paano kung integer cx? So for example, the floor of 1 is equal to itself 1 because, hey, it's already an integer. So there's no need to round down. Now, some of the properties that we're going to need. So if x is greater than or equal to n, but strictly less than n plus 1. So in other words, let's say x is one of those points in the blue segment starting from n up to just before n plus 1, where n is an integer here. So for all these points, their floor is equal to n. So x equal to n plus 1 is excluded because in that case, the floor of x would jump and become n plus 1 already. Okay, so let's go back to the problem. So, daming nangyayari dito. So, ang daming mga different parts and pieces. There's this big M and small m where you have to choose between the floor and between the maximum and the minimum of the floor. Now, so sometimes when you look at the solution to a problem, maayos na nung pagkakaayos, iyon na nung solution. Babasahin mo na lang from step 1 to step 2 to step 3. But sometimes solutions do not show the process that it took to arrive at that solution. And sometimes it's messy as you try to make sense. Ano ba tong function F? Ano nung ginagawa nito? But one thing's for sure, we need to be able to understand this. And sometimes what helps is to consider special cases. So when I attempted this problem, I started by assuming, suppose x is equal to y. Now, the square there on the right consists of all the points xy, such that the coordinates xy are between 2 and 2022. So this is not drawn to scale, but I think it's enough to give us an idea. Ano nung ginagalawan natin. Now, all the points for which x is equal to y are therefore going to be all the points on the line bisecting the first quadrant. So that would be that green diagonal inside the blue square. So gagawin natin, hahanapin natin ano nung mga points xy on that green diagonal such that f of xy is less than or equal to the number 2. Now, because x is equal to y, then their floor functions are the same, and let's give that a name for the common value, small n. And therefore, for the maximum and minimum, big M and small m, we don't really have to make a choice. Fortunately, pareho silang small n, and so we can incorporate that into the function and note that x and y are equal. So when we make the replacements, this is what we get. Now the two absolute value expressions are equal, so you can write that doubled. And furthermore, because n is the floor of x, n is the result of rounding down, x is greater than or equal to n. So parang relationship 3.14 or pi is greater than or equal to 3. So you can drop the absolute value bars. So it's just twice x minus n. So we are looking at the following situation. We want this to be less than or equal to 2. Or you can cancel the 2's from both sides of the inequality. So you get this. And so we have more space because we're running out. Okay, so again, we were assuming x is equal to y, and the floor is equal to n for them. So this is the inequality that we ended up having, which means x is, well, because x is between n and n plus 1, so I marked them on the x-axis, and then the points we're looking at are on the green diagonal, so they must be from within that segment between those two grayish points. But in particular, because of this inequality, we also want x to be less or equal to n, so something over n plus what? This fraction, 1 over n times n plus 1. Now, that's going to be there between n and n plus 1. So observe that this fraction, this is not going to exceed 1. So we're sure that that red point is definitely between n and n plus 1. So if the x coordinates have to satisfy that inequality, then that means the points that we are looking at between n and n plus 1 on the x-axis, that would have to be the points on that particular red segment. Okay, but back to the problem, hindi naman equal lagi nung x is equal to y. So at the start, I was wondering, the different regions we're looking at, are they going to be, well, definitely they're going to include the many different red segments like that. So I was thinking, is it going to be a square like that? Or is it going to be a horizontal and vertical strip? So it was all part of hypothesizing ano kaya mong mangyayari. But anyway, in the end, we're going to see that none of these regions would turn out to be the right region. All right, pero ganun talaga, okay lang. So let's continue. Okay, so earlier I benefited from the assumption that x and y are equal because then the floors of x and y are the same. So, nung maximum and minimum, hindi na kailangan pumili kasi nung kino-compare mo, pareho lang naman sila. So, I thought, what if kailangan mamili? Let's say the floors of x and y are different. So, let's say y is less or equal to x. So, mas nasa kaliwa si y, nasa kanan si x. And suppose furthermore that they belong to these two different intervals. Y is in p to p plus 1 somewhere on the left. X is somewhere on the right between n and n plus 1, where p and n are integers. So that means the floor of y is equal to p and the floor of x is equal to n. So we can see that p is smaller, n is larger. So when we choose big M and small m, they're going to be small n, the larger one, and small p, the smaller one, respectively. So we can make the replacement on the function f. So yeah, the square root of n plus 1, and then the sum of those two absolute values where we replace small m by p. And because of what we saw earlier, how we were able to actually drop the absolute value bars, if you look at the drawing there, kikita natin nung x mas malaki sa p, nung y mas malaki sa p. So nung mga absolute value expressions, we can replace them as they are, just x minus p and y minus p. So here's the thing. So we want this expression to be less than or equal to 2. So that evokes this idea that itong expression na to dapat maliit. Now, nung values ng x and y, so they start off small, pwedeng 2, pero they can be as large as 1,000, 1,500. Yan nga, o hindi lalampas sa 2022. So that led me to thinking of how this first factor is going to be large. And yet we want this product to be small. So kung nung first factor is large, pwede pa rin naman maging maliit nung product nila so long as we guarantee that the second factor is going to be small. All right, hindi pwedeng large pareho, otherwise lalampas na sa 2. All right. Now, if you look at the square root of n times n plus 1, all right, this is the maximum of the floor of x and y. All right. So that led me to go back to the bounds for x and y. So they're between 2 and 2022. So, well, the year now is 2022. So that suggests to me personally na baka hindi naman talaga to useful. Parang pumili lang ng year. Sometimes sa mga math contests, gano'n na ginagamit ng year. But I was wondering how, up to this point, we haven't used yet the lower bound. Bakit kailangan 2? Bakit? Pwede bang 3 or pwede bang 1? All right. Well, because x and y, they're both greater than or equal to 2, and n is the result of rounding down to the integer just below x. So that suggested to me that n is greater than or equal to 2. So, so even if you try to figure out the smallest value of the first factor, the one with n plus 1. So we see that this is going to be larger than the square root of 2 times 3. So square root of 6, it's not a perfect square, but that's larger than the square root of 4. That's a perfect square, which is 2. So nakikita natin na nung first factor, it's not even going to be equal to 2, all right? Hindi man lang siya aabot sa 2 kasi the first factor, in its being large, it's greater than, strictly larger than 2. And yet, we want the product to be less than or equal to 2. So therefore, the only way for this condition, for the product to be less than or equal to 2, the only way for that to happen is that the second factor, this must be smaller than 1. Okay, this must be smaller than 1. All right, kasi even if it's equal to 1, if you multiply that to the first factor, it's already strictly larger than 2. So the product would therefore be strictly larger than 2. But it should be less than or equal to 2. Okay. Now, when I went back to look at the figure, observe that the first term here, x minus p, measures the distance between these 2 points, x minus p. And this is where I noticed that from p to p plus 1, that's already a distance of 1. So, okay, it's possible that x is there at p plus 1, or x is just immediately after p plus 1. But what this illustration showed me is that if you look at the difference of x minus p, that's already greater than or equal to 1. So therefore, if you look at this particular sum, okay, this particular sum, because of x minus p, this is already going to be greater than or equal to 1, even if y minus p is 0. Sabi natin, kailangan mangyari, itong sum na to must be strictly smaller than 1. Which means, hindi to pwedeng mangyari, imposible pa na maging strictly smaller than 1, itong second factor, which means, itong pangarap natin na nung function f maging less than or equal to 2, this is now impossible. Okay, now impossible. Okay, so ano ba nung pinagmulan kasi ng assumption natin dito? We were assuming here that x and y belong to 2 different intervals. And we saw that if x and y were to belong to 2 different intervals, nung f of xy, we cannot make it less than or equal to 2. Impossible yon. So we are forced to this conclusion that x and y must be in the same interval. Hindi sila pwedeng magkalayo for them to belong to different intervals. Dapat nasa same interval sila. All right. So now, let's say x and y are between n and n plus 1. So while x and y may not be equal, at least their floor function values are both n. So big M and small n are both going to be n, and you can infuse that into the function. All right. And then again, just like before, x and y are greater than or equal to n. So you can drop the absolute value bars. And in fact, the second factor, we write that as x plus y minus 2n. So the condition that we want imposed now is that this should be less than or equal to 2. All right, so ito nung kailangan natin mangyari. So x plus y minus 2n times that radical should be less than or equal to 2. Or in other words, x plus y should be less or equal to 2n plus that fraction. Okay, now we're running out of space, so let's restart here. So, all right, so let's say x and y, and they're in the same interval, let's say from n going to n plus 1. So let's go back to the original domain, the blue square. And identified there on the x and y axes are the intervals from n to n plus 1. So therefore, if you look at that particular brown square, this would be the collection of all points xy, whose coordinates, both of them, are between n and n plus 1. So now let's focus our attention on the points within this square, for which the function value will be less than or equal to 2. But we already pointed out that it means this inequality must be satisfied by the x and y coordinates. Now, this set of points, xy, would therefore be a region below a line. And that line has equation x plus y equals 2n plus that fraction. So let's try to see within that brown square, what are the points below this line. So first, let's draw the line by selecting 2 points. Y is equal to n, then x should be equal to that n plus 2 over the square root of n times n plus 1. All right, so how do we know that red point is between n and n plus 1? Because remember, this radical, we argued that this is strictly greater than 2, which means this fraction here, this is strictly less than 1. So that red point would not be able to go beyond n plus 1. And the next, what if this time x is equal to n? So we're looking at the right vertical side of the square. then y should be n plus 2 over the square root of n plus 1. So then if you connect those two red points on the bottom and left side of that brown square, you get the hypotenuse that would be part of the line that we have identified. And so the region below, which is inside that square, is that particular red triangle. So all points xy, whose coordinates are both between n and n plus 1, for which the function value is less than or equal to 2, are then precisely the points inside that red triangle. And so we are interested in the area of such a region. So it's half times the base and height. So the base is this, and the height is equal to the base. And that base is this fraction, 2 over the square root of n times n plus 1. So you square that, multiply it by 1/2, you get 2 over n times n plus 1. This is now the area of that red region. So back to the original problem, we want f of xy to be less than or equal to 2. And we identified how if x is between n and n plus 1, so with y, then the set of points xy satisfying the inequality that f is less or equal to 2 would be points on a red triangle such as this. And this observation applies to other intervals, such as the very first one, the interval from 2 to 3, so corresponding to the case where n is equal to 2. So we are looking at a triangle like this, and up to the very last interval from 2021 up to 2022. So that's for the case when n is 2021. We are also looking at a triangle like this. Okay, so the red triangles that we want, they have different sizes. All right, but of course, mahirap nang i-drawing sila dito such that the different sizes. But for various values of n, the area is 2 over n times n plus 1. So that's how they're going to look like. So if you draw some more of those red triangles, so ganito ng mga points xy, such that f of xy is less than or equal to 2. So too many to draw. So I'll just put dots. And the areas are given by 2 over n times n plus 1, where n runs from 2, 3 onwards until 2021. So this summation S, this is now the sum of the areas that we are looking for. All right, now this is an example of a telescoping series. So in case you are not familiar, I have an addendum to this video. So at the end where I talk briefly about telescoping series, but for those who have recognized that this is a telescoping series, we are able to exploit the fact that each of these terms, 2 over n times n plus 1, can actually be written as a difference, double 1 over n minus 1 over n plus 1. This is a fact that you can verify by algebra. For the unfamiliar, mahirap isipin, but anyway, for now, assuming it's true, well then how does that help us? All right, because the difference is 1 over n minus 1 over n plus 1, when n is equal to 2, so you get 1/2 minus 1/3. And then when n is equal to 3, you get that difference, and then you get many more. So that's the second to the last when n is 2020, and the last is when n is 2021. But of course, do not forget that this is going to be doubled, multiplied by 2 because of this factor here. Now, even though there are so many fractions, we observe that fortunately, a lot of them are going to cancel each other out, leaving us with just 1/2 and 1 over 2022 that we need to subtract, which we need to double. And the computation is now relatively easy and straightforward, of course, after recognizing we have a telescoping series. So this is what we get. This is the sum of the areas, 1010 over 1011, which means with this as A and B, The answer that we are looking for, A plus B, is equal to 2021. This is the answer to problem number 25. Yay! Okay, for those who are not so familiar with telescoping series, so here's an example. Let's find the sum as n runs from 1 to 20 of 5 over n times n plus 2. So what happened earlier in the main part of the solution was we saw how similarly, the denominator is the product of two linear factors, and then the numerator is a constant. Similarly, we can rewrite each of these terms as a difference. So the task now is to figure out how is that difference going to look like. Well, we look at two fractions with denominators n and n plus 2. So let's look at this difference. 1 over n first, followed by 1 over n plus 2, so that the difference is going to be positive because the terms of the series are positive. And then you can verify that this is going to be 2 over n times n plus 2. Well, in the series, the numerator is 5. So we just multiply this by 5 and then divide by 2. So that means the terms 5 over n times n plus 2, that's equal to 5 halves of differences 1 over n minus 1 over n plus 2. So now when we try to evaluate the series, sorry, that's supposed to be up to 20. So here, 20. So instead of adding 20 fractions, let's write each term as a difference. So these are some of what we're going to see. So before the 5 halves, all right, 5 halves. So when n is 1, 1 minus 1/3. This is what you get when n is equal to 2 and when n is equal to 3. And then there's lots to write here. So that's the very last. And then the terms just before it. All right, and then we see that 1 minus 1/3, and then when you go to 1/2 minus 1/4, nothing cancels yet. But when you get to the third group, finally, minus 1/3 plus 1/3. And then we see that, although it's not written here, minus 1/4 will be canceled next. And coming from the right side, we see minus 1 over 20 plus 1 over 20 canceling each other. So it follows that 1 over 19 is also going to disappear. So the only things surviving are these. Fractions whose denominators are 1 and 2, but when the denominator starts from 3 and then 4, mawawala na. And then from the other side, if the denominator is 20 and then lower like 19 or 18, it's going to disappear. But when the denominator is 21 or 22, it's going to stay. So that means the sum is equal to 5 halves times this sum and difference of 4 fractions. Definitely so much better than doing the operation on 20 fractions. So I will not compute this anymore because I just wanted to illustrate telescoping series. So, all right. Now, of course, the time it took to explain this solution is longer than, I suppose, what would be possible or feasible within the Philippine Mathematical Olympiad. So especially when you get to the latter parts, you may not be able to solve them within the time that's provided. It requires a particular kind of skill set. But even if we cannot solve problems on our own, I think maganda pa rin na makita ng solutions. I think there are two levels. We can solve a problem on our own. That would be ideal. But if we cannot, it is still okay for us to be able to appreciate the solution and everything it took to solve that problem. So have a good day, and I hope you enjoyed the solution, you enjoyed this problem, and you learned something new today. Bye-bye.
The Mathematical Society of the Philippines is the country's premier professional organization dedicated to the promotion of mathematics research and education in the country. Founded in 1973, it has grown from a small Manila-based group of math educators to a nationwide network of individuals with chapters all over the country. The Philippine Mathematical Olympiad is organized by the Mathematical Society of the Philippines in partnership with the Department of Science and Technology Science Education Institute. The 24th PMO will be held online in 2 stages, the qualifying stage in February 2022 and the national stage in March 2022. The start of the registration is January 2022. More details are in our Facebook page and also in our webpage, pmo.ph.